My name is Jay von Rosen, owner and principal consultant at JVR Enterprises. Got a couple people working together. I do more of the Azure and Microsoft stuff. We have a guy who specializes more in AWS, and then someone who's been doing a lot of AI lately. Some interesting stuff. Maybe we can get him to do a presentation pretty soon too. He's playing with orchestration and some neat stuff like that. Today we're going to be talking about Azure Data Factory, and it's meant more as kind of an introduction just with the idea that you have all of your on-prem services and you want to get this data out into Azure. And today we are not going to be talking about data analytics. ADF is used quite a bit within data analytics. ADF is actually now part of Microsoft Fabric, which is a suite focused around data analytics. So we're not going to get into that today. We're just talking about moving data. So we're not going to be doing Power Query, no Jupyter notebooks. Not going to be loading to one lake, although it's the same kind of idea. We're just moving data and transforming. I am going to be spending most of this presentation in Azure, just showing how it actually works instead of doing a marketing presentation. But first, I'm going to do a little marketing on this. This was one of the first little explanations of ADF that I found. And when I first found this, I thought, this is like really busy. And then as I learned more and more, it actually became just this perfect kind of overview of ADF. The top part here is all marketing. How do I scroll this? There we go. Telling you some of the, they'll have some marketing phrases in here, code-free ETL as a service, but this does get into all the basic building blocks of ADF. We've got pipelines, and you could think of a pipeline coming from a dev background. Pipeline's really your application entry point. The pipeline is made up of activities, and the activities are, this was a nice little overview here. The three types of activities: you've got data movement, just like copying, you have data transformation, and we'll get into that too, and then control. You do have this ability to do if-then and loops within pipelines with the activities. And then we've got data sets. Data sets are based on linked services, and you could think of a linked service as like connection string, and the data set would be like a table in the database that you're looking at. So you've got to define your linked services. Where am I getting my data from? And then data sets, you'd be setting up to define what you're getting from this connection. And you could do a lot of just moving data around with just that: pipelines, activities, data sets, and linked services. The copy activity, you could do some slight transformations in there, but if you're going to redefine the schema, you'll get into the data flows, and that's where you're doing a lot of transformations. This is, I've been surprised at how powerful these data flows can be in transforming the data and putting it into whatever you want in your destination. And I wanted to talk a little bit about the integration runtimes. That's a piece of this solution that I wanted to show to everyone, of getting all of your local data out into Azure. We have they say the three integration runtimes. You'll have your Azure integration runtime, that's by default, and that's all the compute resources running out in Azure. But we also have a self-hosted integration runtime, and I'll show you how to set one of those up. That is going to give you some easy access to your internal data. And then this also has a couple other things. We won't go in depth here, but variables, parameters, triggers, it will make sense. Trigger just a certain time of day or a certain event happens. This is what's going to kick off the pipeline. So use cases that I'm going to be talking about today, there's a lot of other, but we'll just be doing copying data, transforming data, and then comparing and merging data. So I have a couple demos set up. First, I'm going to talk about setting up a self-hosted integration runtime, and then just do a simple copy of data from on-prem server out to Azure. And I'll do a little small ETL. We'll get into a data flow there, and then comparison, which can be part of the merging of data. So let's jump over into the demos. Okay, so here we are out on my Azure account, and I just have a resource group with everything I'm using for this data factory. I've got the data factory here. I've got a key vault. We're putting anything sensitive in key vault. Data factory will have. Oh, is it not? Let's see. Thank you, Jay. How's that? Better? Maybe a little more. Storage count for saving any flat files, which is part of the solution here. And then my database server, I have the cheaper database server, so I'm just going to make sure that it is running right now. Turns itself off every once in a while. So let's jump right into the data factory. So first thing I wanted to go over was setting up the self-hosted integration runtime. And I was surprised at how simple this is, and it's actually a pretty secure way. Is it still small? Pretty secure way to give Azure access to your internal servers. So once you are in Data Factory, you'll do some of your initial work over here in Manage. And in Manage, we have integration runtimes. And I've already set up a self-hosted integration runtime. Everyone will call it a shear. And for creating your own shear, quite simple. Just go in, you want a new integration runtime, Azure self-hosted, and then you choose between Azure and self-hosted. And they give you a nice little warning here. Data flows, the data flow part of Azure or of ADF cannot run on your self-hosted integration runtime. And the reasoning is the Azure integration runtime, that's running on an Apache Spark cluster, and your self-hosted integration runtime doesn't have all of that infrastructure built in to run like that. So there is a solution to dealing with that. We want to get data from our local machine and then deal with it in a data flow. So I'll go over some of that. And now that we've selected a self-hosted, you just give it a nice simple name, create, and this creates everything in Azure. Now you need to download and install the software on your machine. And when I did this, it was really as simple as just clicking this Express setup. It downloads, it has all of the keys as part of the download. And once you do that, you will have running on your machine the self-hosted integration runtime. You can do some of the configuration here, stop the service, but this is just confirming it's running on my machine right now. So I will delete that little sample one right now. So now that we have access to our internal server and all of our internal data, we can set up the linked services. I'm going to start with Key Vault just because I'm using Key Vault and some of the other linked services. This Key Vault is that one that I showed that I created in that resource group, and then just gave the ADF identity read access to the secrets in Key Vault. And this now we have Key Vault ready for us to store any passwords that we have in our connection strings. So here's our linked service to our Azure database and storing the password in Key Vault. And then the local AdventureWorks connect with the self-hosted integration runtime I created, and then we see server name, database name, and that is, oh, you're not going to be able to read that. This doesn't have a zoom, but that is my machine here with my local AdventureWorks. And then also I do have storage account. I have a storage account for staging files, and we'll get into that. That's where I'm just going to copy data from on-prem into a storage account to then use in a data flow, and then report files. So now that we have the integration runtime set up, linked services all set up, we can get into authoring. And first, we need to set up the data that we're going to access. So the linked service, we set up the Azure Database Link Service. So when you're setting up a data set, say what linked services is this connecting to? And then I just specify the table. This is my Azure Departments table, my Azure Employees table, and my Azure Employee Departments table. Now these can be used in pipelines and data flows. And then we have my on-prem AdventureWorks using my local AdventureWorks, and you notice it's forcing it to use my self-hosted integration runtime here. This I did not specify a table. You don't have to specify a table, and I'm not in the data using this as the data source, because when you are getting data from a data source, you can use a SQL query, or you could use a stored procedure. You don't have to get directly from a table. So now that, yeah.
So I was actually thinking of replicating that database. You're saying that it's doing the queries like in real time.
Yeah, yes, yeah. When we set up a pipeline, and here's a good example. You set up the pipeline and you can say you have the copy data activity. These are all the activities, and copy is right here. But with the copy, you can say from the source, I'm going to specify just a SQL query as the data source. So in this simple copy of data pipeline that I've set up, you can see we can do some mild transformations here. For salespeople, I'm going to just say there's an is sales flag, and I'm taking things from the person table and the employee table, and I'm just going to be putting that into an employees table rather than having it in two separate tables. But once it gets out into Azure, just to simplify. So basically, any kind of transformation that you'd be able to do just with a simple select, you really would only need a copy activity. And let's see, so this copy does that select, and the destination is my Azure Employees data set, which was my Azure database with the employees table. And it automatically recognizes, because I selected everything with the same names from that select, it handled all the mapping automatically because it would get the schema out of the table and then say, well, employee good goes to employee good. This is a simple mapping here. And in this same pipeline, I'm going to copy over the department's data too. Oh, one thing I wanted to mention in employees is that in the legacy AdventureWorks, business and entity ID is the primary key, and I've decided that I want to do the employee GUID as the primary key on my employees table. So I'm copying over the legacy entity ID just so we have it in Azure for any sort of lookups. And then departments, it's a very similar sort of thing in that I'm saying I'm copying from the on-prem AdventureWorks, and then a simple select to get the data out of there. And then I've decided I wanted to add imported date to this data set coming over too. So that in my departments table, I have a new column added on that says when this was imported into Azure. And this is where we get some of the expressions in ADF. You do get quite a bit of functionality in the expressions. You have a lot of built-in functions. Just expand all, and you can see you'll be using expressions in quite a few different places, but this is just an example of one place you could use this, is where I want to put in some dynamic data. And then sync is just going right into my Azure departments. Since I'm copying that ID right out of Legacy and I want to put it into Azure with the exact same ID, you can have a pre-copy script in here. Of course, the SQL user that I am logged in as has to have this permission to do the set identity insert. But you can execute some pre-copy scripts to make sure that you have that you are able to insert identities into the destination. And then mapping, I thought this was kind of nice. It gives a little warning here because that imported data, I used that UTC now function, which returns a string, and it's saying you're trying to put this into a datetime offset. A string to a datetime offset might lose some data, but since it was a function that creates a datetime offset, I figured it was safe. So I'm just ignoring the warning here. And that will get us the data from Legacy, and then employees. And there's all of our data out in Azure, copied over with is sales flag. Can't think of any other, but employee good as the primary key on that one. So that's a nice simple copy over, but now we have our employee department. Since I changed my primary identifier on the employees table, it's not the business entity ID, it's employee good now. So now I'm going to need to have my employee departments table. I have to migrate that over, and instead of using the business entity ID, mapping over to which employee is in this department, I've got to look up the employee good. So this is where you'll see that the data flow, it's not going to have access to the shear. So what we do is we are just going to copy from our on-prem database, just get the business entity ID, department ID, and modified date from the source, and just put it out into a storage account. And that storage account I set up just to take a parameter. Let's see. This guy has a parameter here that says the file name that this is going to be stored in has to get passed into me whenever anyone is using this. And then right here, I say I am in my staging migration, and then this is the file name that we're looking for. Okay, now that we have this CSV copied out to our storage account, then we can call the data flow. And this is going to do that mapping to get the employee good based on the business entity ID, and then put the data into Azure. You see that since this data flow is using that same data set that is the migrate staging files, it's using that as a source now, and that's in the data flow. We'll see in a second. But when I'm calling the data flow, it's saying we're going to need the file name for this legacy employee department's data source in the data flow. So it will ask you for that. It'll give you errors if you don't specify. And now we can jump over to that data flow. And then here is our storage account as data source. And that's that migrate staging files. We passed in the file name when we called the data flow. And yeah, we just have that set up as the source. I'm going to turn on the debug. It takes a couple minutes for it to start up. So I'll turn this on now. And then our employees table, which we've already migrated out to Azure. This is our Azure employees data set, which just maps to our employees table out in the Azure database. Sure. And then we were going to get it with a query. We only need the employee GUID and the legacy entity ID from the employees table. Now that we have that mapping that we need from the employees table, and we have the employee department's CSV, we join those two on the business entity ID, which in the employees table is called legacy entity ID. Very simple, interjoin on the two IDs. Then we're going to add another date in here, add an additional column and say that we imported this data at the current UTC time. And this will add an additional column to that stream. And then it's simply putting it into the sync. And sync would be your destination in a data flow. The sync being the data set, and it's the Azure Employee Departments table out in Azure. So relatively simple transformation, but there is quite a bit of functionality in here. You can branch out to have different, multiple copies of the same stream if you want to filter one copy of the stream one way and another copy a different way. You can add derived columns, and I'll show a little bit of that later. This one I was surprised that it had in here. You have pivot and unpivot as well. So basically any type of transformation that you want to do on your data, you have this functionality within a data flow. And let's see, next we were going to go into, now we've got all of our data out in Azure, and we still have our legacy data, and just imagine that we're updating both at the same time, and we want to just we want to make sure everything is in sync, that if anything's changed in Azure and it didn't get replicated back to legacy, or didn't get written back to legacy with the same process, we've got a comparison pipeline here. Similar type of thing is that we're going to copy the legacy data out into a storage account so that we have our legacy data within the data flow, just written out to a CSV. And this is the same query that we saw when we were migrating the employees. And then we're going to call the compare employees data flow. And this will ask me for all of the parameters that the compare employees data flow needs for its data sets. So you see we've got file names that it needs, where we're going to write the files to, showing the differences. And we'll jump over into the compare employees. This is where it gets a little more complex. Let me see if I can, how do you zoom without a mouse wheel? Oh, that was right. Oh, no, I've zoomed in too much. Okay, so we have two data sources. Our legacy employees, this is our CSV out in our storage account. And we want to compare that to our Azure employees. So this will pull in all of the fields that are available in each of these data sources. First thing I want to do is I want to rename the legacy columns just so that once I do a join, I can tell the difference between each different column because they'll have the same names. So I just put an L at the beginning of each one of the columns just to indicate this came from legacy. And this was another neat thing that I found in here, is a lot of the functionality that you have in those expressions, we also have the ability to do hash. So this was as simple as, come on, open expression builder. There we go. Doing a SHA-256 of all of the fields that I wanted to compare. One thing to note, this will make sense when you think about it, but might not think about it at the time. You got to make sure that everything is in the same case, of course, and these are the same data types, because string 1234 is different than integer 1234 when you hash them. So now we have a hash for all of the legacy columns that we want to compare, and the same thing with Azure. We did a hash of all of those columns. And then a simple join of legacy to Azure, and doing a full outer join where the legacy entity ID is equal to the Azure legacy entity ID. And then we have a filter step in the data flow where we just say everything where the hashes do not match, those are not the same. And let's see if we've got the data preview working here. These will not have differences right now, so I don't know why I decided to show you that one as the data preview. But this is going out and getting the data from the sources and running the pipeline here. I had to do the data flow debug, which starts up debug instances of the cluster that's going to be running the data flow. So while that's getting that data, I'll show you we've got the unmatched employees, and then I split this into different streams. So at this point, we have 3 copies of the same data, and this is where I'm going to say everything that's not matched, I'm just going to write to a report file out on my storage account. And this will just be a flat CSV with all the columns from legacy and all of the columns from Azure, so that you can visually see what's the difference between these two. But then also created some data sources for the syncing, where I say the one who was most recently updated in on-prem, they're going to have the legacy updated at is going to be greater than the updated at. We can filter however we want, but we say we're going to assume whichever one was updated last, that's going to be the one who needs to get synced back to the other data source. So legacy updated at is greater than the updated at in Azure, then that goes into the on-prem most recent, who just gets written out to storage account CSV that says these are all of the rows that need to be updated in Azure. And then similar type of thing here in Azure was updated most recently. So I'm going to write those into a CSV indicating what needs to get synced back to on-prem. And let's see if my data preview has finished yet. Oh, yeah, it has, because I had manually gone in here and changed some data in Azure. I set up the first employee I had changed his title to doctor. I think my database has gone back to sleep. Oh. Let's see my results here. Okay, I'm seeing them over here. I'll just copy this. Put this over here. So you see, I had updated the title for our CEO to Dr. Ken. when in legacy, Ken did not have a title. And one other thing, this is just a little bit of a gotcha. Set. Let's just set that back to what it was. And we will refetch our data to see if the discrepancy has disappeared. And now you see that it says the exact same thing. This is a bit, this is because we have all of these, this cluster that is, each of the nodes, it has put copies of the data that each node is going to worry about on each of the nodes. So this is one thing you'll need to just go in here, say in the refetch it from the original source and put it out on all of the nodes in the cluster. And as you can see, that takes a little more time, but there we go. Now everything is in sync. So how am I doing on time? I think I'm good. Of course, you'll get in here and probably one big question you'll have is, what kind of load is this going to put on my database, on my destination database? And it can be significant because even these small clusters, this is going to be at least 4 compute nodes who are all doing bulk inserts into the destination at the same time as fast as they can. So you could have a database server that works fine supporting a couple thousand users because they're just selecting username or from the database. And all of these nodes are doing bulk inserts all at the same time as fast as they can. So we have run into situations where the destination database is getting overloaded. You can do things after hours, of course, but if this is like a production database and you don't want to overload your production database, we've come up with a couple different little solutions. Probably one of the most useful is that when you are copying this data, first thing that we did is we split this data up in the data source into a bunch of different chunks. You see you have partition options in your select here. And if you say dynamic range in that select, I can now load this in, here we go. I don't know if you can read this part, but you need to put in your select, you need to put a filter in there. So I'll just drop that in there real quick. And this is something that ADF will use to filter the data that it's getting when it's creating each of these partitioned files. So you're going to need a column that you're going to partition on. Simple one that we did was just let's pick business entity ID. And you say mod 10 or something like that. Now this is going to have 10 different values, 0 to 9. And then you could just say partition column name is partition. And now you have 10 different files. You could do this with parameters too. You can say, you could pass a parameter into your select to say, this mod 10 will say we want a variable number of partitions specified when we run the pipeline. So if we want to do 20 partitions. Now that we've partitioned this out into 20 separate files, for example, then we have that ability with the, we do have to filter these files, and then you just load those files, and that is in the get metadata. You can get metadata to get the list of files, and then in the for each, you would just go for each one of these files, pass that file to the data flow. And we found that data flow is going to do all of its processing. It's going to think for a little bit, and once it's done, it's going to do this massive insert. So we would get spikes. It'd spike for a couple seconds, then down while it's processing, spike for a couple seconds, rather than being spiked for 5 minutes straight and killing the database. One thing to be sure that you check in here is that when if you're doing a for each and you want them to go one at a time, there's a sequential option that is not enabled by default. You have to click this sequential, because otherwise it's going to do for each on all of them at the exact same time and you're back where you started. So those are a couple things that we ran into. Are there any other questions? Yeah. You're talking about just like either database backup and then upload it out into Azure. I like Data Factory more for, we've got the transformations built in there. If you're gonna rethink your schema out in Azure, then putting it through a complex transformation and having a repeatable process that you can then, repeatable and auditable process that you can then go back again later and then say something was wrong or you wanted to add more data. Now you can just rerun that whole migration. So I like ADF for that. One thing to note about ADF though is if you're using it for small chunks of data, because this is spinning up a bunch of compute nodes at the beginning, that's going to take a couple minutes, then it runs, and it's not going to seem a lot faster than just maybe doing a select to CSV and copy and then import the CSV. But for very large data sets, we've done 100, 120, 150 million rows, and ADF, once it gets the clusters spun up, then amazing how quickly it gets through all the data. So I like it for that, but yeah, not if it's just simple copies, things like that, maybe you'd want to use ADF just because you have all your field mappings all right there, and you can go back later and say, oh, that's why that's wrong. So the auditing aspect of it. Well, one of the things is the organization of all of the pieces here. You can set up folders here too. So you could have a folder where you have pipelines that do this sort of thing. Pipelines can call other pipelines, and this hit me like after I'd finished this whole presentation. You know how I did the migration. It was copying data, and then I did the comparison. It's copying the exact same data. So I had two of those exact same things. Really could have been its own pipeline that says, I copy data to a storage account. I don't care what you do with it. And then the compare and the migrate would both call that pipeline, because pipelines call other pipelines. So segmenting things out, similar to like the code reusability, where it's like, this is going to do one thing. I know it's going to be reused. I do have a shared directory for pipelines in a couple of my data factories.
So kind of following a little more of a separation of concerns.
Yeah, yep. Yeah. And we have folders that say, these are all comparison pipelines. These are all, trying to think of some of the other pipelines that we have, migration pipelines. So organizing with the folders, having the parameters too, especially if you're doing your development in a development environment, integration environment, and this is going to be out in a production environment that's got different connection strings and different things. So you will have your pipelines. I have a couple parameters here, and you'll see default values in your build. While it's doing the build, this has the ability to generate the YAML for a build pipeline too. And then in that build pipeline, you can say, if environment is integration, these are the parameters that I want to substitute. And then, each different environment will have their different parameters. And then also making use of things like, we have global parameters too. I don't have any in use here, but you have global parameters that are defined for everything in the entire data factory. Usually, so far, I've only had like 3 or 4 global parameters, because a lot of times the pipelines are like, they only have their specific parameters that they need. And those can be specified in your build YAML too. So, anything else? Or, well, great. Yeah. Thank you all for your time. Thanks for coming. I think I'm a little early, am I? Yeah. Well, good. Thank you very much.